Welcome back. This is the video for questions 73 and 74. You are in for a doozy because 73 is one of these hard ones. So if you missed it, you're in good company. A lot of people miss this question. I'm going to need the formula sheet. So I'm looking on the formula sheet and it wants me to do a 95% confidence interval, but I can't do a calculator because they don't give me any of the information I need to plug in. So I need this formula and I need to look where I see this confidence interval. So the confidence interval is the statistic plus or minus the critical value times the standard deviation of the statistic. And this is definitely a proportion question because it says it, so I need that formula. So, again, I'm going to write out what I see on my formula sheet. A 95% confidence interval, colon, would be the statistic plus or minus the critical value times the standard deviation of the statistic. So I'm just going to jot this down on my paper. 95% confidence interval is the statistic plus or minus the critical value times the standard deviation of the statistic. Then in this table, it tells me the standard deviation of the statistic of a proportion question is that. So that's useful. And then in a proportion question, our statistic is just our p hat. What proportion did we get from our sample? So I really just have my critical value times the formula, the square root of p times 1 minus p over n. And I'm square rooting that whole value. So ultimately, the margin of error are these two numbers multiplied together. You need a number here and multiply it by the critical value. And the critical value comes from table C for confidence interval. So on my paper, I'm going to write table C. And for a proportion in table C, it's easy because I can scroll all the way down to the infinite button. And when I look at the infinite button, the value for table C, critical value, for a 95% is 1.96. Okay, so the critical value is 1.96 if I'm doing a proportion question for a 95% confidence interval. So I can plug that in. That part I do know. And most of the time, my calculator does this for me. So now they're saying what would be the smallest sample size, so I'm actually solving for n, that would guarantee a margin of error. So again, a margin of error is this part, the critical value times the standard deviation of the statistic. So that is my margin of error. I simply need to solve for n. And when I'm trying to figure out, I'm guaranteeing the biggest or the most conservative, I assume that p, or the proportion of people, would be a flip of a coin, or 0.5. So if people were merely just flipping a coin and answering a question, even odds would be 0.5. And that's going to be my most conservative. So I'm going to plug that in. The proportion is 0.5. 1 minus 0.5 is also 0.5 over the letter n. Now remember, I'm solving for n. So I need to have this value be greater than or equal to my margin of error. And so I add that to my formula, 1.96 times 0.5 times 0.5 divided by n, take the square root of all that, has to be greater than or equal to, because I'm trying to be conservative, my margin of error. Now they told me my margin of error is 0.08. So I can plug that in, and now I got to do algebra. So this is probably the first time in the class you've actually had to do algebra. So never fear, at least once in your life, remembering these skills is not the worst thing that could happen to you. So I'm going to go back over to my other paper here where I actually worked this out. Lots of little work here. So 0.08 is equal to the critical value times the square root of 0.5 times 0.5 over n, take the square root of the whole thing. So notice if I take 0.5 times 0.5, I get 0.25. And I've got to get everything over to one side of my equation. So I divide 1.96 on both sides, and so that cancels. And so now on this side of the equation, I just have this expression with a square root, and on this side of the equation, I have my 0.08 over 1.96. Now technically, it probably makes sense that this value is a greater than or is a less than or equal sign. That actually, let me fix that. That's actually more accurate. Now as you follow through on this, I'm going to take the square of both sides. And when I compute that in my calculator, then that goes away. So I end up getting 0.25 over n is equal to this value. So now I still have to cross multiply, solve for n, and I get 0.25 over that amount, and I end up getting the value 150. So all that computation, and I end up getting 150. So I need a value greater than 150. I've selected 175, and that is the answer. It feels like kind of a vague question. This was the question. This was the year. This was an actual question, and it's a very debated question. Let's go to the next one. The next question, 74, so I'll let you look at my clean copy. The process of producing pain relievers is all about an active ingredient. There's a claim that the average amount is at least 200. So that's like any product. This product right here, they claim that there's 8 ounces. So for them to put an 8-ounce label on here, there at least has to be 8 ounces here because that's their claim. So when I think about that, the consumer watchdog tested 70 at random, so that's plenty. That's greater than 30, and they got a mean of 1.943.3. We want to know if that's evidence of their claim not being true. So when they said at least 200, that made me think this is going to be one-sided. We know that the product might be more. They're not going to get in trouble if it's more. We're suspicious of them because we believe it might be less. So N is 70, X bar is 194.3, the standard deviation is 21. We have all the information to plug this into a calculator. My degree of freedom, if there's 70, 70 minus 1 is 69. So if this was a free response question, we're going to put a lot on here, but it's only a multiple choice. So let's get our calculator. I'm going to go menu, statistics, stat test. Oh, is it Z or T? I'm not sure. Notice, though, nobody told me the standard deviation of the population. So I'm forced to pick a T test, not a Z. And they did give me the statistics. So a lot of kids get hung up. They're not sure which to push. But obviously, I didn't have raw data. I didn't take 70 of these, and I have the raw data here. So I have to pick. They gave me the statistics. I click that. I click OK. And here's all the information I'm given in the problem. So I'm just filling this in. What is mu naught? That's 200 because that's what they're saying is in the product. X bar is 194.3. So we do have some amount of evidence. It's less than 200. Standard deviation is 21. N is 70. And I'm going to set the alternate hypothesis. I believe mu is something less. So here's my screen. I have set a one-sided test. And all the numbers fit. I'm going to hit OK. And I end up getting a p-value of 0.013. The closest value is A, 0.012. So what kind of notes might you take on this question? I actually was at home and I had to do this one by hand. So if you do it by hand, you use the tables, and I was able to narrow it down that it was somewhere between 0.2 and 0.1. Either way, though, we're definitely, and that number is between those values. So I got A if I did it by hand, and using the calculator, I get a value that's closest to A. So I believe the reason why they put A is that the person that wrote the question did the question by hand. That's definitely your answer, though. Thanks for joining us.